Greetings, Earthlings. Today we're going to test the front panel of the stupid computer. I have completed wiring all the boards. Well, I still have to add the status LEDs to this one, but this is the front panel driver and teletype board, and the other two, which yeah, look at that. And this one fully, and this again, this will have so this is the microcontroller board. This will have the status lights on it somewhere, and you can see the stacking connectors. So those will line up like that and plug together. But we'll get to that later. What I've done here is, here's the front panel. I've installed some chips. These chips here, these two are the drivers for the PC lights. I didn't install the others because then they would have floating inputs, and then you just get random lights coming on for the other rows, and we don't want to see that. And then here I've jumpered the switch outputs, which come through one of these ribbon cables and then out to ultimately the bus and then on to the other cards. Jumpered the switches to the PC output bus, line on the bus here. So what would normally be the PC register output is just going to be from the switches. Power is on, and so if I flip a switch, what should happen is, whoa, look at that. The corresponding PC light should light up. And no other lights should light up. Okay, so there's that. It's beautiful. Okay. So far, so good. Now, you can trust me that I've tested actually the other rows here, the accumulator, memory address, memory data, and they work as well. Let's rewire it, and I'll turn the camera off for that. Rewire it and test the momentary switches here. And we're back. Time lapse. Woo! Okay, what I've done, just to prove I wasn't lying, I have moved the chips from here to here. So we're now driving the accumulator lights, and you can see they're on because these all have inverted signals. The last two I left wired to these switches, so you can see that still works. But basically, that's going to be reset, stop, and so on down the line. So if I press reset, oh, nothing happened. Oh, wait, okay, so that one works. Look, load and stop. Oh, that one doesn't work. Oh, that one works. Examine next, deposit next. Okay, so what's going on here? Well, this is actually a good lesson. The switches come through a Schmidt trigger. And there's a front-end filter on the switches, well, on a Schmidt trigger. This is coming from the switch. The switch has a pull-up, and when you engage it, it grounds this line, okay? Now you'll notice, maybe you will, maybe you won't, I'm going to tell you that there are two different varieties of chips here. This is a 74HCT14, and this is a 74LS14. You'd think in most cases they're interchangeable, right? One's faster than the other one, uses more power, draws more quiescent current, things like that. But in this case, because of the resistor on the front end, the low power Schottky device will not work in this instance. If we look at the data book, and I don't have it here, I should have it. If we look at the current you have to sink out of that input, if you want that to go to 0 for the low power Schottky device, it would limit this series resistor to something like 300 ohms or so, and it's 7.15K. This one, being a CMOS part, has virtually 0 current, so you can pull that down quite easily. So I think I tested this circuit on a breadboard with the HCT part, and then when I drew up the schematics, I drew them up as LS parts because I had a couple of LSs. I only have one of the HCTs. So I put in my old LSs with a whatever 77 date code. Let's see. No, 1975 date code. Wow. So anyway, that's what's going on there. It's not a problem. It just means that I need a CMOS part here as well as here. Well, what about this side of the board? What's over here is the serial port. And we can do a little testing on that. What I will do there is let's wire up the switches so that I can send a character out over the serial port to the trusty dusty Silent 700 terminal. So the baud rate is set at 300 baud here. This is the baud rate generator. This we don't need for now. This is the UART itself, and this is the RS-232 voltage converter chip. So again, let me pause, and we'll rewire it, and we'll try sending some characters over that serial port. See if that's wired up reasonably close to correctly. And we're back. Okay, so what I've done is I have wired up. Oh, and see, notice I was talking about floating inputs. Notice those lights are all on now. Okay, I've wired up the switches to go to the ALU lines on the bus. The UART is driven off of the ALU. And then the deposit switch will tell it to actually print the character. I've got my little cheat sheet here, which has an ASCII code chart. So I am going to try to let's see, deposit. Oops. Are we having fun yet? I can't see the terminal right now from where I sit, so I don't know that it's actually printing out the message that I wanted, that I'm intending it to be printing. But you can see it, and hopefully I've come close. And I don't know if you can read that on the screen either. But anyway, let me go over and take a look and see if I got it right. Okay. Well, it looks like I messed up on one of the spaces there, which was probably me. I did notice when I pressed the deposit switch that the head didn't move, but I thought it was just being smart because that was supposed to be a blank. Anyway, that's basically working. And so I guess that's it for now. More testing to come.